Let's take a look at section 3.5 where we look at rational functions and their graphs. First, let's look at the definition of a rational function. Rational functions are quotients of polynomial functions. This means that rational functions can be expressed as f of x equals p of x over q of x, where p and q are polynomial functions and q of x is not zero. The domain of a rational function is the set of all real numbers except the x values that make the denominator zero. Let's look at an example of a rational function. H of x equals x plus 6 over the polynomial x squared plus 2x minus 24. Let's find the domain of this function. When I find the domain of a rational function, it's very important that the denominator be in factored form. So notice it's the denominator that I need to factor at this point if what I'm doing is finding the domain. So x squared plus 2x minus 24 factors into x plus 6 times x minus 4. Now, the definition stated that the domain is the set of all real numbers except the x values that make the denominator 0. So notice our denominator is this factored expression. So our denominator, which is the quantity x plus 6 times the quantity x minus 4, is what I cannot have equaling 0. So the only way this product is going to be 0 is if either x plus 6 is 0 or if x minus 4 is 0. So that's what would have to happen for this denominator to become 0. But remember, my issue is I do not want the denominator to be 0. So that means I need x plus 6 not equal to 0, and I also need x minus 4 not equal to 0. So that gives me two inequalities. I'm going to solve the first one by adding a negative 6 to both sides of the inequality. I'm going to solve the second one by adding 4 to both sides of the inequality. So x can't be negative 6. And in addition to that, x can't be 4. So remember what the definition says. The domain of a rational function is the set of all real numbers except the x values that make the denominator 0. So the domain of h of x is all of the real numbers that aren't negative 6 and that aren't positive 4. Typically in a MyMathLab problem where you were asked to find the domain of this function, you're going to be asked to give the domain in interval notation. So if I can use any real number except negative 6 and positive 4, that means I can use all the numbers left of negative 6. So that's represented by the interval from negative infinity to negative 6. That does not include negative 6, so I enclose that with parentheses. Negative infinity is never included because it's not a number, it's a pattern of behavior. It indicates an indefinite movement to the left. I'm going to unite that with the interval that represents all the numbers between negative 6 and 4. And notice I don't include the endpoints, negative 6 and 4 of this interval, because x can't be negative 6, nor can it be 4. And then I'm going to unite this with the interval of numbers that are to the right of 4. Notice, again, I'm not including 4, and I never include a negative infinity nor a positive infinity because those aren't numbers. Those are patterns of behavior. So I can move indefinitely to the right of 4. And this is the domain of my function.